We're on the last chapter of this book now that I've been working through, so thank you if you've been following along the entire series. We are going to be working on surface area volume. Okay, so in this first section, it's about the surface area and volume of prisms. Okay, so before we dive into the problems, as with most videos, I'm going to give a little intro, a review, and then we'll dive into problems. So, there's lots of formulas that you could memorize. For example, you could memorize the formula for the surface area of a rectangular prism, and then you could memorize a different formula for the surface area of a cube, and then another formula for the surface area of cylinder, another for cones, another for spheres. So you can see no matter the shape, or for every shape, there's a different formula. That's not a good idea. Similar for volume. You have equation for the volume of a rectangular prism, a pyramid, a cube, a cone, a sphere, whatever else shapes you want to do. So there's too many formulas, and if I probably said this in some other video, I personally hate memorizing a bunch of formulas. I feel like it's pointless. Instead, this is how my geometry teacher actually taught me it. For volume especially, for volumes of prisms, instead of memorizing a bunch of formulas, memorize that volume of a prism is area of the base times the height. Okay? And then surface area is just the area of each face of that prism, which is not that difficult. Okay, so that one's a more conceptual understanding of what surface area is. You're going to find the area of each face, and then you're going to add them all up. Volume, just remember area of the base times the height. Okay, so for example, if you want the volume of a rectangular prism, as I was saying, it's like length times width times the height. Or you can memorize it as area of the base, which is a rectangle, so length times width, and then times the height. Okay? A cube is just a special case where the length and the width are equal in length. Okay? But you don't need to memorize that as side cubed. Instead, again, if each side is like x, it's area of the base, which is x times x, and then times the height, which is x as well, so x cubed. Okay, so I would recommend you memorize that one simple formula for volume, area of the base times the height. Okay? Now, let's begin the problems. Let's see how difficult they can get. They honestly are not that difficult most of the time. You just got to be able to apply those few formulas. Okay, the figure above shows a cement block of these dimensions with two 10 by 8 openings. What is the weight of the cement block to the nearest gram? The density of cement is 1.7 grams per centimeter cubed. Okay, so how do we do this? I'm asking for weight. So you probably want it, technically, this is not precise in that it's asking for weight, it's asking for mass actually. Weight is in like pounds. Okay, it includes the force of gravity. Mass does not. But that's getting a bit technical. Not the point of this problem per se, but that's whoever wrote this question did not do a good job. I always, if you've seen my other videos, love picking on people who don't write good questions. Okay, so how do we get the mass or the weight? Well, the clue is the units. Okay, so the density of cement is 1.7 gram per centimeter cubed. So we probably need to get something in the unit of centimeter cubed. Which is that? Is it area? Is it volume? It's volume. Volume is three-dimensional. Area of the base times the height. 3 dimensions. Okay? So we need to get the volume of this guy. How do we get the volume of that guy, though? This block here. Well, we can find the volume of the big entire block and then subtract the volume of the two holes. Okay? So what's the volume of the hole? Let's say V hole Area to base, 36 times 20, times the height, which is 9. Okay, if you put that into a calculator, that's 6480 centimeter cubed. Okay, because notice cm times cm times cm, so centimeter cubed. Okay, and the volume of, I should say entire, but whole without the w, whole is equal to, what is the dimensions? 8 by 10, that's clear, right? The height is still 9 cm. Okay, so what is that? That's 720. So the volume is actually 6480 minus 720, and then minus another 720, so times 2. Why 2? Well, there's 2 of the holes, right? So that is 5040 centimeter cubed. Okay, so we found the volume of this block. Now we can multiply by that density, because 5040 centimeter cubed times 1.7 grams per centimeter cube. The centimeters cube units would cancel. So that is 8568 grams. Answer is D. So again, units are a big clue a lot of the time, so use them to your advantage. Don't drop them. Figure above shows an aluminum block, or aluminium, wherever you're from. Aluminum block of 10 by 8 by 12 inch with an 8 by 6 by 12 opening. What's the weight of the aluminum or aluminium block to the nearest pound? Density of aluminum. Okay, so this is the exact same type of question, right? As before. So the volume, entire, let's say this time, is area to base, 10 times 8, times the height, which is 12. Okay, which is 960 inch cubed. Okay, volume of the whole is 6 by 8, so 6 times 8. The height is again 12. That's 576 if you punch it into the calculator. Okay, so the volume is 960 minus 576, which is 384 inches cubed. Okay, so the weight is 384 inches cubed times 0.098 pound per inches cubed. The inches cubed would cancel. Now this is the actual weight. It's in pounds. Again, this is more precisely mass, if you want to get technical. So this is what? 37.632 pounds. Okay, to the nearest pound, so 38. Okay. Manufacturing company produces cardboard boxes by cutting out square corners 3 inches by 3 inches from rectangular pieces of cardboard 3x inches by 2x plus 2 inches. The cardboard is then folded along dashed lines to form a box without a top. And the volume of the box is 162 inches cubed. What's the dimension of the original cardboard before cutting out its square corners? How do we approach this one? Okay, so to use that this volume is 162 inches cubed, what are the dimensions? This dimension is how much? So let me go from here. So this entire thing is 2x plus 2. But then we cut off, how much is that? 3 and another 3 over here. So it's 2x plus 2 minus 6, which is 2x minus 4. That's this dimension here. Okay? Now what about this dimension from here to here? Similarly, it's 3x minus 3 minus another 3, so 3x minus 6. Okay? And the height of the box would be, remember, if you fold it up, how much is that? That's this length here, that's 3. Okay? So 162 inches cubed, that is 2x minus 4, that's one dimension of the base. 3x minus 6, that's the second dimension of the base, times the height, which is 3. Okay, so we can solve for x, and so let's drop the inches cubed first, okay? We're going to keep in mind the units, though. And it totally makes sense, because inches times inches times inches, inches cubed, right? So how do we solve this? Well, what's 162 divided by 3? This should be a calculated question. So that is 54. And then if we expand this out, that is 6x squared minus 24x plus 24. Okay? Now what do we do from here? Well, we can subtract 54 on both sides. So 6x squared. By the way, it's a calculator question, so if you have a graphing calculator and it's allowed, you can just use a graphing calculator. I don't know how it works with the online test now, but I'll do it by hand anyway. Minus 24x. 24 minus 54, that is minus 30. Okay, I can divide by 6 everywhere, right? So 0 is equal to x squared minus 4x minus 5. So that's equal to x minus 5, x plus 1. So x is equal to 5 or negative 1. You can't have a negative length, right? So we cross that one out. We say x is 5. Okay, now we got to answer the original question, or the dimensions of the original cardboard before cutting. So it was 3x, so x is 15, and 2x, 10, plus 2, that's 12. So 15 by 12. Answer C. Okay. Aquarium tank in the shape of a rectangular prism is 20 inches long by 16 inches wide by 12 inches high. If 2,400 cubic inches of water is added into the empty tank, how far is the surface of the water from the top of the tank? So, how do we do this? Well, this much water got added. So we can even draw what's happening. So pretend this is 3D. Okay, so this is the rectangular prism just from the front, okay? Imagine it's 3D. And then your water is somewhere here. So you're asked about this distance. Okay, so how do we do that? Well, how do we get the volume of the water, just the water? 2,400 is, well, the shape that the water takes is the exact same shape as the tank, the prism. So what's the dimensions of the prism besides the height? Is 20 by 16. Times the height of the water. This h is the height of the water. Now we just divide and solve for h. H is 7.5 inches, okay? So over here is 7.5, and we know the entire height is 12. So how much is left? 12 minus 7.5, that's this remainder, right? So what is that? 4.5. That's the answer. Okay. So that's how, these are some possible problems that can come up. This is a very common question even in calculus, if you ever take that class, when you have to optimize. I've seen this many times where you have to optimize like the volume of the box, and then you have to cut out like these sections like that, exactly like this. Okay. Otherwise, another key concept is you can subtract volumes. So just imagine it's like water. You can take out that portion of, pretend it's like a tank within a tank, so you can just take out that portion and so subtract the volume. Okay. That's it for this video. In the next video, we'll be doing similar for cylinders and spheres. So I'll see you in that video as usual. Oh, as always, please like and subscribe if you found this video helpful in any way.